Hi everyone, my name is Anna. It's my first time in America, so obviously my first time at Conch, and I'm really excited, and everything looks great from here. I live in London, where I work as a data engineer for a big data startup called Mastodon C. Mastodon C provides its clients with big data analytics and open source technology platforms all around built environment and smart cities. I've been programming in Clojure for over a year now. So as it usually is with small startups, I've been doing loads of everything, so backend, frontend, wherever's needed. Most of our projects are open source, so feel free to look them up on GitHub. I've been using OM for the past several months, and as OM grew, so grew my knowledge of it. And I'm not saying I know everything, and I'm pretty sure there's still loads for me to learn about structuring client applications. But I wanted to share with you what I've learned so far, what were my, oh, so this is how you do moments, and oh God, why is this not working? So I wanted to create a background for that. So I thought dashboards are useful and pretty. So I'm going to talk to you about OM and dashboards, and I hope you'll find it interesting, but most of all useful. What is a dashboard? Dashboard is a communication tool. It's not meant to be an analytical tool. The purpose is just to display data, to provide it to the user in a clear and easy to understand way. The typical things we might want to show on a dashboard are values or something. So we might want to show sales and the progress of sales. We can allow for comparison. We might want to highlight the danger and success by showing where certain values reach specific thresholds. And we can also easily share the results with others because we can make this dashboard available to a group of people. But most of all, we don't have to log into several applications. We don't have to dig into the logs. We can have this one-stop shop for all the information that we need. There are quite a few libraries and applications already available on the market, so you're probably wondering why would anyone want to build a dashboard from scratch if you have all these tools out there. So I think the truth is, I think no one created a tool that can match everyone's needs. If you build the dashboard to one group of people, I'm sure another group of people will want something else, and you might customize it. You can try to make it as generic as possible, but you will always reach the point where we'll eventually want an option that's just not there. And if you're into Clojure, you probably want to have both the backend and frontend written in the same language. And with so many cool ClojureScript, Clojure, and JavaScript libraries out there which you can use, it's very easy to just pick wherever you want, plug it in, and mix and match, reuse, share this tool with others. And it's a good UI programming exercise as well. So if you're new to ClojureScript, it's a good exercise. So before we jump into the technical bits, let's do just a quick dashboard prep, because we're going to do some visualizations, and it's good to know what you shouldn't do so you don't make someone angry or you don't make someone's eyes burn. The most common and very clear way to visualize data are tables and charts. Tables are great for values. It might be tempting to make the tables very fancy, too fancy even. I wouldn't do that. It's good to just stick to pure data, because otherwise it's just distracting and unnecessary. Another type of visualizations are charts. They can be either bar charts, line charts, scatter plots, and so on. They're great for showing how values change over time and among different categories, and they're also great for comparison. But the thing to remember is that just because you can visualize something, it doesn't mean that you should. The first principle of data visualization is don't visualize. Always ask yourself whether showing the same thing with just raw data isn't doing the same job. If you take this as an example, we just want to show a number of open GitHub issues last week versus this week and the variance between them. So the bar chart looks sort of okay. It's a little bit too much just to see how this week's is comparing to last week. The line chart Well, you have to look at the date that the points are showing. You see that the value is decreasing, but you can't tell by how much straight away. So it's just too much. And if you look at the table with raw data, this looks like the perfect solution. But of course, this is great for small data sets, and if you want to show some trends in your time series, you should visualize those. Pie charts. They are colorful, I give you that, and they make me think about pies, and I like pies, especially with gravy and mash. You probably prefer like apple pie or pumpkin pie, but that's not the point. The point is to clearly convey information. And that example, we want to show some stats around people the number of people liking a specific type of films. The pie chart, I mean, there are so many colors. You have to match the category, the label to that color, and the triangles they might look very similar. You have to look at the numbers on them. So there's a lot of going on. It actually makes my head spin a little. And the bar chart just does the job. It shows you look at the first bar, and that's the largest number. You know that the sci-fi is the most popular type of the films. So no fancy colors, just data, and data is good. And 3D. I mean, it doesn't add anything. It's actually distracting, because you're looking at that additional dimension, thinking what is the meaning behind that. And if you look at the rotated stuff, I mean, why would you even do a 3D rotated visualization? So never ever do that. The data ink ratio is a concept introduced by Edward Taft. Edward Taft is considered a guru of effective information presentation. So the chart on the left is an example of low data to ink ratio. So it's very cluttered. You have the border around the chart, you have the background color, the shadows, the grid lines, the trend lines. It's all unnecessary. The chart on the right has a high data to ink ratio, so nothing is distracting you from the data. You just have the data. So the thing worth remembering is that we shouldn't let the design shout louder than the information, because the data should always come first. But you should always try not to overwhelm the user with the amount of information that you're passing. So it's just a simple matter of finding the balance. So not that we've covered the data viz, I'm just going to talk about the components and what we could use actually to build those. I'm pretty sure most of you heard about React already, but for those who didn't, I'm just going to quickly explain. React is a declarative framework that solves the problem of complex UI rendering. It focuses on transforming data into interface components, and the data can come from the servers, user input, you name it. The common way of building UI is to first render your template and then wire up events between the model and the DOM. So when something in your model changes, you would then query the specific piece of your DOM, and if it needs changing, you would update the properties on that DOM. So this works okay for small UIs, but there's a performance penalty if you're going to do that sort of thing multiple times in a single frame of execution. This is because the querying and updating the DOM are very expensive operations. And this also produces loads of boilerplate code. So React is an implementation of one-way data binding. The developers describe the document tree, and React takes care of figuring out what needs to be updated. It maintains this fast in-memory representation of the DOM, which we refer to as virtual DOM. And the render methods in React return the description of the DOM. So React does this serious performance optimization where it recursively diffs between the previous and the next UI renders, and determines the minimal set of operations to execute, like add element, remove element. And because most of the UI changes result in very small DOM alterations, this results in very fast UI, even if it's a very complex UI. And we produce much less code, and our components update faster. There are quite a few Clojure script interfaces to React. There's Reagent, there's Quiescent, and there's I've been using written by David Nolan. Hi, David. I'm pretty sure you're here. We all remember from earlier that React does a diff on the virtual DOM. So there's this very critical function called should_component_update, which when it returns false, React won't compute the children of the component. But because JavaScript developers tend to mutate objects and arrays, the default implementation of should_component_update is very conservative. It always returns true. So if a developer wants to make the UI more performant, they actually have to provide their own implementation, and they have to manually walk the JavaScript object and find out what changed and whether they actually have to update something. Some relieves us from that tedious work by using Clojure script data structures, which we know will never mutate. And because of this, we can provide a component that implements should_component_update by doing the fastest check possible, the reference equality check. So we can always find out what paths have changed, starting from the root in logarithmic time. And we don't have to worry about optimization because delivers better results than if we chose to use React out of the box. So the data structure used for storing the application state is a tree. And because we always have the entire state of the UI in a single piece of data, we can easily serialize that. So we can snapshot the state in memory and reinstate it wherever we want. So we get undo for free. And this is actually memory efficient because the data structures work, they share the structure. As I said, a web application with has this global data, global state, which is an atom, and all components down the tree access it through cursors. So cursors are a triple that consists of data to render, a path into the global state, and the reference to the global state. So in this example, if we have a component that was given a cursor, which is the first element of a vector, which is called data, which is inside of a map called films. So the cursor would look like the thing highlighted in the blue box. The value would be the first element of the vector. The path would be the path to that element. And the state is just a reference to the atom, reference to our global state. So you can think about cursors as windows into the application state, and all components down the tree, they only see what they can see through that window. They don't see all of the application state. So the biggest mistake I've done when I was creating my first application was to build my components by passing in the cursors that they needed, but then realizing that I didn't have some information I needed, so it wasn't available in that particular cursor. So I was doing lots of silly things. I would pass in more of the app state, or I would pass additional argument, which would be an app state, or I would just pass the whole of the app state to all components. And it worked okay because the UI was small, so there was no performance problems. But once the UI started growing, this was really, really slow. I mean, imagine a table with rows, and clicking on a row in a table and highlighting it was changing the application state. But because all components had the same cursor, the same application state, they were all being rendered when I clicked on a single row in the table. So lesson learned, don't pass more of the app state to the components that you need. There are other ways of passing additional information around. You can update the app state, the cursors, by using update and transact. You might be tempted to use swap because it's an atom, but if you choose to do so, you are losing out on the reference equality check because you are bypassing So I don't recommend that. I would always use update on transact. So there's also local state, which is local to single component, and it cannot be seen outside of that component. It's best for transient state. So for example, when you're dragging something around your screen, you might want to store the coordinates in local state, but once you stop dragging, you should store the final coordinates in the app state. And it's also good for storing corresponding channels, and it can be updated by using ohm's setState function. There's also shared state, which is accessible by the entire tree, so all components in the same tree under the same root can access the shared state, and you don't have to pass it from component to component because it's always there. But the thing about shared state is that it doesn't trigger renders. So it's good for storing corresponding channels or some static information, but don't expect to store something in shared state and have UI updated when something changes. So dashboards usually consist of various widgets, and we can easily use ohm's components to create those. Since we can use JavaScript interop, there are plenty of data visualization libraries out there which we can usually use with ohm. And most of the time I use D3 and dimple. D3 is awesome at producing interactive SVG visualizations. It can manipulate any part of the DOM, and it has loads of functions to compute our visualizations. So ohm works on the DOM as well. So we're in a bit of a pickle here because both libraries want to be in control of the DOM. So to make use of both libraries, we can either use D3's helper functions to compute our paths, projection, and scales, and then feed that information to ohm and have ohm create the SVG and manage the SVG. Or we can have ohm render an empty div inside of our component and allow D3 to work its magic and create the pretty charts. So the latter option is the most popular one, probably because we leave the decision whether to render component to ohm, and then we allow D3 to do what it's best, what it's doing the best, so actually drawing things. So we're combining the best of both. But D3 is quite complex, and if you're a beginner, then you probably are better off using a higher level library. And dimple.js is an example of that kind of library. It has a very simple API, and you can create a bar chart in just a few minutes. And if you find yourself in need of tweaking some features that are not exposed through the API, you can always use the underlying D3 functions. So these were the pretty things, but there wouldn't be any pretty things without data. And the data can come from the API, from the database, from the SharePoint, wherever you want to use. And so once you know the sources of information you want to use and what's the refresh rate for those, you can choose from a number of options. So the simplest one is to just refresh the web page and have the components to fetch data when they are being mounted into the DOM. But that's not very efficient. So another way is to set an interval at which components will pull data. So you can use JavaScript's interval to do that. But yet another approach is to use long polling or HTTP streaming or WebSockets and have the server push data to the client. So WebSockets and long polling might sound like a complicated thing to do, but there are loads of libraries that actually make it easier. There is an HTTP kit which not only gives you the server, but it also supports WebSockets and long polling. But there's also Sente, which goes one step further. Sente has been written by Peter Taussanis. And it adds corresponding channel to the mix, which is great. So you get this bidirectional asynchronous communication between the client and the server. So you have Go blocks in both the client and the server, and you handle the messages in them. And Sente just works. It auto-keep alives, it buffers, it reconnects. There are also other libraries that are doing very similar thing, but I haven't had a chance to use them. So I'm going to show you a very quick demo. I think I am. Yeah. Okay. So that's a very simple dashboard. It doesn't have much, just two charts. The chart on the left is a D3 chart, so it's a stacked bar chart. All the data comes from GitHub API. And it's just these are just the stats on this open source project that my team was working on. So this chart shows you the code frequency stats, additions and deletions per week. And the charts on the right show you the contributor stats. So they show you the number of additions and deletions per user for the week that you selected on the left. And you can kind of choose what interaction you want to enable. So if you enable click, you have to actually click on the bars to have the thing on the right updated. Or you can use hover, and you can just hover over the data, and it will update the view. And there are 3 views that you can choose from. So you can have the charts rendered, or you can use some cards which work the same way, but just display information in a different way. You can have a simple table in case you just want to copy and paste it, or something else. And there are also some simple widgets that show you the number of open GitHub issues and number of open pull requests. And you can see what's the refresh rate and when was the last time it was updated. But I think it's showing UK time zone at the moment. So initially I wanted to show a faster refresh rate, but because these are weekly aggregations of GitHub stats, there's no really point in refreshing that more often that it's being refreshed. So I'm going to show you what I used to actually build that. So for my dev setup, instead of creating the project structure myself, I used lining and template called Chestnut. Chestnut is awesome. It includes Figwheel. Figwheel automatically reloads your Clojure script and CSS. So whenever you save your changes, it actually refreshes everything in the browser for you. You don't have to actually go to the browser and refresh it manually. And it includes Weasel as well, which is browser-connected repo. And everything is nicely built around So I highly recommend it. And here's a bit of a setup that we need to make in both the server and the client to make the communication possible. This creates a channel socket. Clients can use channel socket send API function to send messages to the server. And the server can likewise send events to the client using the same API. So this hides all the messy setup. This is what you need to actually create the communication between your server and the client. The code for the demo is actually available on the GitHub under my account. It's called Pumpkin. So if you want to have a look and use it for something, feel free to do so. I was inspired by pumpkin spice latte. So the main idea is that our server has a Go loop in which it processes events coming through the specified URL. And our client will have another Go loop where it listens to the events coming from the server. So in this example, the server gets the URL and the interval with which it should push new data to the client. So it fetches the data from that URL, it sends it to the client, and then it sleeps for the duration of our refresh rate, and then it repeats that. Obviously, you might want to fetch data from a database or somewhere else, because fetching from another API doesn't really makes sense. This is just an example. So when the client receives new data from the server, it updates the app state accordingly, and everything on your UI that needs to be refreshed refreshes. So it's simple as that. That's the starting point of the UI. The application model is a map. Each key represents roughly a different component. Application is attached to a div with an ID app, and I use the shared state to store corresponding channels there. So event channel goes to the main chart. So when you hover over something or you click on something, the timestamp on which you hover over is being put down the channel. And also we have a multiple of that channel, which is being given to other components and they can tap into that multiple. So this way, when we distribute the timestamp to all of the tabs get that timestamp. An application component sets up the event loop in will mount. So this is where we handle all the messages coming from the server. And render function initially displays loading dashboard while waiting for the channel socket and the session to be established. and then builds the actual dashboard. And the dashboard this is the entire UI, and we pass in the URL for the repository that we want to display the stats for. And that's the repository view. So you can see that each component, there are 4 components, and each component gets a different cursor, so a different part of the application state. So I learned my lesson, and whenever something changes in the application state, the components will update accordingly. And here's the code frequency stats. So these are the views that were shown on the right-hand side. Depending on what view user selected, OM will render a different component. So multi-methods are great for that, and I'm really glad that we can use them with OM. So the code frequency stats are stored in our application state, but each component might want data in a different format. But at the same time, I don't want to change the underlying raw data. I want to use the same raw data, but the components need to transform the data before it's actually being rendered. So if you map or reduce over a cursor, you will get a copy of that data, but it won't be a cursor anymore. So you could use an update function and store that new copy of the data in your application state, but then you would either have to override the existing data, or you would need to store it in a different part of your app state, which is just a duplicate of your data. So there is a FN option that you can pass into your build function, and you can pass in the function that you want to be applied on the cursor, and it will apply that function, and the cursor will actually remain the cursor, so you're not losing the benefits of a cursor. And that's the chart stats component. The tables and the cards all look the same. Maybe not exactly the same, but very similar. They are all initialized with a channel that taps into the shared channel. And they all have go loops where they store the received value in local state and update the selected or hover over a week to a new date. The thing to remember about tap, that each tap must accept before the next item is distributed. So if a tap is slow, it will actually block the multiple from processing the next item. So it's good to remember that you should always use buffering channels if you think that one of the taps might be slow. And another thing you should remember is that you should untap your components and you should close the channels if you don't need them. And you can do so in will unmount. That's the render function of the chart stats component. So I'm using a reference cursor here. This is because depending on what user interaction is chosen, whether it's click or hover, I want to either disable or enable transitions. So when we hover over something, I don't want the charts to jump up and down because it's really annoying. But because the selected user interaction is in a different part of the application state, the chart stats don't have access to that. So using reference cursor allows us to actually use see information that's in a different part of the application state. So you can observe the reference cursor, and you can then react to the changes that happened in that cursor. So when user selects a different interaction, we will want to redraw the charts with the transitions enabled or not. It depends. So how does the actual charting code look like? That's the simple dimple chart component, so the small charts. And in will mount, I added an event listener, so I'm listening to whether the window resizes. This is because when you resize the window, the SVG stays the same, so you actually have to re-render the chart to make it appropriate size. So in that event listener, we just update the application state with the width and height. The render function renders empty div, and did mount and did update do the same thing. So this is because the did mount is called once when the component is mounted to the DOM, but we want to actually also react to changes in our application state, so we use did update as well. And because with dimple, if you draw the chart to actually change something on the chart, you just have to get rid of the old chart and create a new one. So before I draw the chart, I just remove the node with the old chart and attach a new one. So that's the code to draw the chart. It's all JavaScript interrupt. There's nothing more to that. It creates the SVG. It adds X and Y axis. It adds the series. It's very simple. And if you were to do that thing in JavaScript, it would look very similar. And that's the main stacked chart, a stacked bar chart. And as I said earlier, D3 doesn't put sugar on anything. The actual function to draw the stacked bar chart, including the legend and the event listeners, is about 100 lines of code. So I'm not going to show that. I just show you the most important thing, which are the event listeners. So depending on the interaction selected by the user, we either listen to click or mouse over, and we put the information on the timestamp on of the bar that we hover over down the channel. So that's it. So just to sum up, there are lots of cool libraries out there, and it's worth spending some time to try something out, because who knows, maybe it will be the next big thing, and it will make your life easier and UI programming fun. And don't be afraid to use JavaScript interrupt. I know it doesn't look as pretty as Clojure script, but JavaScript has been with us for so long that there are so many cool libraries out there. And if you wait for the libraries to be ported to Clojure script, I mean, what's the point of doing the same thing again? Just use them. And the same goes for data visualizations. You can use them easily with OM, but you can use them with Reagent or whatever framework you're using. They work well just as well. And always share your components, share your tips and tricks. When I was starting with OM, it was quite tricky. There wasn't as much discussion going on online, so I had to learn the hard way from my mistakes. But there are loads of people discussing their UI programming on IRC channel, on the Google groups. So participate and share what you've learned. And I hope you found at least one useful thing in this talk. And I'm more than happy to talk about it during the break. And if you think I could have done something better, let me know. I'd like to learn more. But please don't talk to me about 3D pie charts that are rotated. So thank you. What now? Oh, yeah?
Can you go into more detail about what your opinion is about reference cursors and maybe like how the code looks with it versus without, and what your opinion and how that turned out in practice?
I haven't used them very extensively, so I use them in production, so I have them put into the code. And they've been great, because sometimes using corresponding channels to access that tiny piece of information seems like an overkill. So having a reference cursor, which just makes this particular bit of information available to you, I think it's great. It solved a lot of problems I had. So it makes the code base a little bit smaller. But then if you want to rely on loads of reference cursors, then you will have loads of defs defined in your namespace. So I guess you just have to keep the balance.
In your opinion, do you think there are any drawbacks or negatives?
I haven't really found any drawbacks or negatives, no. Any other questions? Thank you.